Okay, so the register below can hold its value if green equals 0. Now when you see a color, he just uses those for variable names. Green, that's green, blue, yellow, those are always variable names. If green equals 0, or shift right if green equals 1. So what it's saying is if the variable green is 0, so that's this one, if it's 0, then it shifts right. And by shift right, it means that the value in this register goes to this register, and the value in this register goes to this register. It holds its value. If green is 0, it holds its value. So if green is 0, it goes back to itself. And if it's 1, it shifts right. So this is just giving you an example of a circuit that does something like that. And now it's asking you to make a similar register that can shift left if yellow equals 0, or have each flip-flop take as input the AND of its current output with black if yellow equals 1, where the serial input is left in and the serial output is left out for the left shift. So that seems like a lot of stuff. And so the way to get started without being overwhelmed is to know that you're going to have 3 flip-flops. And the only reason we know 3 here is because it says to do a similar one. Otherwise, he would tell you how many. And you can always fill in the clock. If you don't want to draw the clock line, you can usually just say, not going to draw the clock line for clarity, but you should say that. But it's easy enough to do, especially if you are, at this point trying to figure out, I don't know what I'm doing. Well, I know I need a clock. Let me go ahead and put that in there. And whenever you have a situation where you have an if, you're going to do one thing if this is true, or another thing if this is true, then that means you're going to have a multiplexer. And so that's always going to be the case. And so we're going to have a multiplexer with each flip-flop, just like in our example right here. And the S in the multiplexer is the select that tells you which output to choose. So again, even if you're not sure what you're doing yet, you can draw your multiplexers, your muxes. And I usually put my S on top. He has his on bottom, and I'm just going to copy the way he has his. It doesn't really matter if it's on top or on bottom. And I have a slight tremor in my hand, so my lines are always a little crooked. So S, S, S. And the S is going to be where the signal comes in. That's the signal that tells you which of 2 things you're going to do. Or if you have 4 things, you're going to have 2 signals coming in because they'll be binary, and you'll have 0, 1, 2, 3, 4 on the side of your multiplexer. But that's going to be the one that tells you what you're doing. And since at this point we have similar register that can shift left if yellow equals 0. Okay, so we know that yellow is going to be the variable name for the thing that's telling us what to do. So we can go ahead and draw that, and we can have that going into the S port of our multiplexer. Okay, now the multiplexers all have a 0 and a 1. I'm going to finish, usually I do this first. I'm going to finish drawing my flip-flops. Our registers are usually going to use D flip-flops if you want the easiest kind of register. So I'll have a D and a Q and a D and a Q and a D and a Q. And he usually starts his numbering with the smallest number on the right. So just to keep, and it can be different, there's different conventions. This is the way that he does it, and there's reasons why people have different conventions, but just to keep your stuff looking like the way he does it, I recommend doing the same. So it's basically counting down. So this one is number 2, this one is number 1, and this one is 0. And remember, with computers, we always start counting with 0. Okay, so now it's time to actually figure out what we're doing. So it will shift left if yellow equals 0. So shift left means that the flip-flop on the right, its output is going to go to the input, to the one to the left. So shift left. So here 0, flip-flop 0, is going to go over, and it's going to go into the 0 terminal of that multiplexer. Now, I forgot to connect my multiplexers to my flip-flops, so I'll do that right there. And so what that is saying is if this signal yellow is 0, then it's going to feed the value that's coming into the 0 port, and the value that's coming into the 0 port is this flip-flop right here on the right, and that's going to be what it is. Now, so that's 0 going to 1. Now to shift left, we're also going to have 1 going to 2. So I have 1 going to 2. And we don't have anything going to flip-flop 0. And that's where we're going to look and see what it has. Our instructions here is where the serial input is left in and the serial output is left out for the left shift. So that means since there's nothing to the right of flip-flop 0, we have this variable that we're going to call left in. And that's going to go here. And then since there's nothing for flip-flop 2 to go to, there's nothing to the left for flip-flop 2, it says its output is going to be left out. So I'm just going to draw that and label it left out. Okay, so we've taken care of yellow equals 0. Now, if yellow is 1, the flip-flop will take as an input the AND of its current output with black. So we have a new variable that we'll call black. I'm the worst at these. Don't have enough room. Okay, so I'm going to have a variable that I call black. And those are just wires. It's just a wire that has a signal on it. And if yellow is 1, I want the input to be the AND of the output of that flip-flop and black. So
I'm going to have black, and I'll have an AND gate, and I'm going to take the output of that flip-flop and AND it, and it's going into the 1 of the multiplexer, because this is supposed to be what happens when yellow is 1. It's supposed to take that. So for flip-flop 1 here, again, I'll have an AND gate. I'll have black. I'll have the output from flip-flop 1. And that's going to go into the 1 terminal of that multiplexer. And one more. And I'm sorry, I'm so messy with those. If you want to see a better picture, this is the 2020 test, and he does have this posted. Let's see if I can pull it up. Yeah, so that picture is a little neater than mine was. Not just a little neater, quite a bit neater. Okay, I'm going to go on to the next question. You can find, like I said, you can find